When I talk about object-oriented programming, I often talk about these four pillars of object-oriented programming. And it's not that I think it's important that you know what these four pillars are. I just think they are instructive about what we consider to be important in object-oriented programming. One that I haven't talked about yet is polymorphism. And in this video, we're going to talk about polymorphism in the context of arrays. And we're not really going to go any deeper than that. We're not going to go into any other uses of polymorphism. But in order to understand what we're doing, you are going to need to know how to use arrays, and you are going to need to be fairly familiar with inheritance at this point. You need to know how to extend classes and need to understand how method overriding works. So polymorphism gives us the ability to treat instances of different classes as if they were objects of a shared superclass. Well, what the heck does that mean? What it means is that if we have a checking account and a savings account object, we can treat both of those the same as long as we're treating them as bank accounts because they both inherit or they both extend bank accounts. So that means that regardless of whether it is specifically a checking account or specifically a savings account, we can make withdrawals, deposits, we can get the balance, all those shared elements of those two subclasses. Now, the advantages of being able to do that may not be obvious right away, so let's take a look at how this applies to something like an array. If we consider that we have made an array of checking account objects that hold 6 instances, I can put, obviously, checking account objects in that, but if I try and put a savings account object into that array, it doesn't work, right? And this goes back to our basic understanding of arrays, which is they can hold a collection of things as long as those things are all of the same data type. What polymorphism says is that if we change this array and instead of making it an array of checking accounts, we make it an array of bank accounts, now that savings account can go in that same array. And we can have an array that holds a mix of any subclass of the bank account class. And we can interact with those in an array. And we've already seen that when you have an array, first of all, you can hold big amounts of data, but just as importantly, we can run loops through that data and we can process it really efficiently. So this gives us a way to handle all of our accounts in one array. Let's take a look at how this would work in code. Here I've got this array of checking account objects, and I've attempted to put 6 instances into that array. And the ones that are using the checking account constructor are working just fine, but anytime I try and use that savings account constructor, I'm getting a compiler error. As we discussed just a moment ago, we can change this from a checking account to a bank account, and I'll have to change it in both places here for the moment. Now, those will at least compile. I'm then going to deposit money into them. I'm going to run it real quick just to make sure it really is working. And it is. There's no output because this program doesn't produce any output yet. And let's just start by doing a traversal loop to go through and get the balances of these objects. So for int I equals 0, this is just our good old-fashioned traversal array. And so now I'm going to print out the balance for each of these in order. Balance equals, and we'll just say accounts I dot get balance. Let's go ahead and run that, see if that works. So we are off and running. The idea here is that we've already seen it working because in the lines of code here where I'm making deposits, I am successfully calling superclass methods for instances of each of these subclasses. So it is working, but the more important thing is that in my array, I can have this array of as many accounts as I want, and each element in that array can be from either subclass and it will still work. There are some implications here to be aware of. One of them, for example, is that I can't call any methods that are specific to one of the subclasses. So if I say accounts, and let's pick one of my savings account 5. Well, I'll just put I, we're in the loop, so I'll put I, and I'll say add interest, which is one of my subclass methods. That's a savings account method. That won't compile, right? Because it's looking at this as a bank account. Remember, in polymorphism, we're treating the subclass as the superclass, the subclass instance, I should say. And so it's looking at it as a bank account. It's essentially starting that method call up the inheritance tree. It's starting at bank account because I've said that that's what the class is. And that's not specific to the loop. So if I take this up here, because that maybe that I makes it confusing, right? Because it could we never know what it's going to be. But even if I pick something that is explicitly a savings account, that still doesn't work. Now, we have some tricks that we're not going to get into here because it's kind of beyond the scope of this short little video, where we can maybe make that work. But instead of going into depth, I just want to show you a little example of that, or a hint of that, I should say. And that is that we do have a way, we have a couple ways we can test an object from this array and see which class it is. And so if I say accounts I dot get class, so there is a method called get class, and you can see in the output here it's saying checking account or savings account. Well, where did that get class come from? We recently have learned where that probably comes from. When we call get class, it's going to look at bank account first and doesn't see a get class method there. So every class in Java inherits from a class called object. Remember, it's one class to rule them all. Well, get class is a method in that object class. So any object in Java, we can call get class and find out what it is an instance of. Speaking of instance of, we can also make that an if statement by there's a Boolean, it's not really a method, it's an operator, but I can say if accounts I instance of savings account, and I misspelled savings account there, I put an S on the end. So this instance of is a Boolean operation that compares whatever's on the left to whatever's on the right. Well, sorry, it looks at what's on the left and says, is this an instance of the class that I refer to on the right? And it's going to return a true or false. Now, it's not quite as simple as then saying, well, okay, we know it's a savings account now, so let me just add the interest. It's not quite that simple. There we have to do some downcasting and some things that, again, are beyond the scope of what we're doing here. But I just wanted to point out that we're not stuck. We do have some options there. The other thing that's a little more relevant to us now with what we know so far is that regardless of what the instance of returns, without us having to worry about it, our method calls will move up the inheritance tree in terms of overriding. So if I go to my savings account, I haven't overridden deposit here, but if I do that, if I say public void deposit, and we'll say double amount, and I'm just going to say system out println. This is a worthless override, but it shows the point. This is a savings deposit. And so now I can just do my superclass deposit with the amount, and I don't have to add any other code. So now if I come back to my test method here, my test program, and run this again, And we're really looking at these lines of code up here. So anytime that we call a deposit method, it is moving up that inheritance tree. I think I kind of misspoke a few minutes ago. We are still going to move up that inheritance tree in terms of overriding, right? And it's not clear what's happening because they were sort of mixed in here. But every time we deposited to a savings account, it ran this this override version of that deposit method, and so it spits out that little line of text. The point here overall is that we are still able to create an array of bank accounts, put the subclasses in it. We can't call the methods that are specific just to that subclass, but if we call a method that's overridden, it will respect that and it will call the correct version of our overridden method. So this really has been just the very briefest look at what polymorphism is. It has a lot of implications beyond just arrays, but arrays of subclasses is something that we can put to use right away. And in fact, I'm going to ask you to put it to use right away. And it builds very logically on what we just learned about in arrays. As is always the case, if there's been anything in this video that you're not sure about, please reach out.